This is our circuit that Brian and I have been working on that will launch rockets for us. I'll go over the different components and tell you what they're for, and I'll show you a demonstration of how it works. First of all, with these two black wires, this is where our power comes in. This will come from an array of AA batteries. We'll go through this, a 5-volt regulator, and be conditioned by this capacitor here. The power goes to our PIC microcontroller, which handles all of our I/O as well as firing and timing and that sort of thing. With the PIC, we need a crystal and a couple of capacitors. These provide a clock for the PIC. The main purpose of the PIC is to actually fire the rocket, and that is done through this transistor, a diode, and then of course a relay to switch the higher voltage for the rocket launch. All of our I/O comes over this wide ribbon cable to our second board. The small ribbon cable provides power to the second board. On this second board, the main components are this black IC, which is a buffer chip or an array of transistors which prevents the PIC from supplying the current to light the 7-segment display. This buffer package provides power to this resistor network, which limits the current to the 7-segment display. The 7-segment display provides a 10-second countdown for the rocket launch, so that we know how much time is remaining. These 3 LEDs over here are indicator lights. The bottom green one is simply a power light, which tells us when there's power applied to the circuit. The yellow light tells us when the countdown is active. And the red light simply says that we're ready to fire and we're waiting for the start signal. Over here we have a couple of transistors and some resistors. The 3 resistors are current limiting resistors for these 3 LEDs. These 2 transistors basically switch the yellow and the red LEDs so that the current is not supplied by the PIC microcontroller. Down here we have 3 resistors. These 3 resistors are pull-down resistors so that the PIC always sees a low signal whenever the buttons are not pushed. These buttons are our abort button, our reset button, and our start button. In the way you use the controller, the first button you push is usually the reset. This puts 10 seconds on the clock and gets you ready for the countdown. Normally then you would press the start button, which starts your countdown and starts the 7-segment counting down from 10. Now if you encounter a problem or you want to stop, you'll press the abort button, which will then stop the countdown and flash an A on the screen and stop everything for 5 seconds. So at this point I'm going to go ahead and apply power, and I will show you how it works. Notice when I apply power, our green power light comes on, and you saw a little bit of an initialization process with the 7-segment display. Now I will go ahead and hit the reset button. We have 10 seconds on the clock, and our red LED signifies that we're ready to shoot. Next, I'll go ahead and start the countdown. Yellow LED comes on, initiating the countdown. 3, 2, 1. I don't know if you could hear it, but the relay clicked, indicating that we did in fact close the circuit and the rocket will fire. Normally this will be in an enclosure, and it will have a battery pack as well as some external connections for our higher volt, usually what's going to be a 12-volt source to actually launch the rocket. Once we get it all mounted in the enclosure, I will go ahead and take some video of that and show it to you. Here's what the enclosure looks like so far. We have our power switch. This is going to be our reset switch. It's a momentary rocker switch. Also, you're going to have these 2 are our start switch. So you have to press both of these in order to start the countdown. And then the large red button, of course, is our abort switch. You'll see 3 small holes for our LEDs. We have yet to cut the hole for the 7-segment display. Once we get this all cut and everything mounted, I'll go ahead and show that to you as well.